Welcome to our scientific analysis of Alberto Beretti's seminal paper on ultraviolet blood irradiation, or UBI. While seasonal influenza remains a relentless global health burden, avian origin strains like H5N1 pose a severe pandemic threat, with case fatality rates exceeding 50%. Conventional antiviral therapies, such as neuraminidase and polymerase inhibitors, face narrow treatment windows, rising drug resistance, and an inability to control the destructive host immune response. To overcome these limitations, Beretti proposes re-evaluating ultraviolet blood irradiation as an adjunctive platform featuring a distinct dual-strike mechanism. First, UVC photons in the 254 to 266 nanometer range directly disrupt viral single-stranded RNA, halting replication without triggering drug resistance. Second, irradiated leukocytes undergo photochemical hormesis, activating transcription factors like NF-kappa B. This rebalances the cytokine milieu, suppressing pro-inflammatory drivers like TNF-alpha and IL-6, while promoting anti-inflammatory IL-10 to prevent fatal lung damage. Interestingly, UBI is not a new concept. Originating with the not-hemo irradiator in the 1930s, it was successfully used for bloodstream infections before being sidelined by the advent of antibiotics. Beretti draws a compelling analogy to the electric vehicle. Just as early electric cars were abandoned for internal combustion engines, only to return with extraordinary force today, UBI was shelved simply because antibiotics offered an easier interim solution. Today's crisis of antimicrobial resistance and pandemic threats warrants its modern resurgence. However, a rigorous scientific evaluation requires separating mechanistic rationale from clinical proof. Beretti transparently notes that no direct peer-reviewed experimental data for UBI against H5N1 currently exist. Existing preclinical support relies on older or unpublished studies, such as the Fagan study reviewed during an FDA investigational new drug application. That study demonstrated significant reductions in lung macrophage infiltration and pulmonary inflammation in animal models, supporting the immunomodulatory hypothesis. Rather than advocating for immediate clinical adoption, Beretti makes an urgent call for systematic, modern research. The proposed agenda prioritizes four key pillars: determining precise inactivation rate constants across specific influenza subtypes, including H5N1, validating cytokine rebalancing in standardized animal models, establishing dosing parameters leveraging established extracorporeal photopheresis safety profiles, and conducting rigorous clinical trials to prepare our therapeutic arsenal before the next pandemic strikes. In conclusion, Alberto Beretti's review establishes a robust photochemical and hormetic foundation for ultraviolet blood irradiation. By combining direct pathogen photodamage with host immune modulation, UBI offers a theoretical breakthrough against lethal viral infections, where conventional drugs fall short. Systematically investigating this historical tool with modern science is a vital step in global pandemic preparedness.